Hello and welcome to Morehouse's Math Menagerie. Today we're going to be talking...
Morehouse! You ate my snack pack out of the fridge again.
Hey, there's no one's name on it.
Well, you've done it for the last time.
Hello and welcome to Morehouse's Math Menagerie. Today we're going to be talking about one sample significance tests for a mean. The problem we're going to be addressing is that in a report released by the Department of Education in Idaho, stated that 1,100 students took the AP Statistics exam in 2016. The mean score on these exams was 2.63. In that same year, Mr. Morehouse had 68 students take the AP Statistics exam. His students' scores had a mean of 2.84 and a standard deviation of 1.367. Is there sufficient evidence at the 10% level to suggest that Mr. Morehouse's students have a mean score on the AP Statistics exam that is different than the mean for the state? To answer this question, we're going to run a significance test on the mean. Step 1 for our significance test is to define our parameter and hypotheses. So let mu be Mr. Morehouse's student's mean score on the AP Statistics exam. Our null hypothesis is that the mu is going to be equal to the state's scores of 2.63. Our alternative is that mu is different than the state's mean, so mu does not equal 2.63. This indicates that we will have a two-sided test for this significance test. And we have our alpha at 0.1. Now, step 2 is conditions. First, random sampling. We are going to treat Mr. Morehouse's 2016 students as a random sample. Independence, we're going to check the 10% condition. 10 times the sample size is 680, which is less than 1,100 students. For approximately normal here, we know that our sample size is larger than 30, so the central limit theorem applies. Step 3 is calculations, and we're going to use a calculator for these. The first thing we want to do is list out our statistics. Our x bar of 2.84, s is 1.367, n is 68. And since we're using a t-test here, we need to show our degrees of freedom, which is 67. Now, if we go to t-test in the calculator and select statistics at the top, we know that our mu naught from our null hypothesis is 2.63. Our x-bar is 2.84. Standard deviation is 1.367. And our sample size is 68. We select that mu is not equal to mu naught, since this is a two-tailed test. And when we hit calculate, we end up with a test statistic of t equals 1.2668 and a p-value of 0.2096. You'll notice I also listed out the formula for the t-test statistic. Now, I want to take a second to look at the graph of what our p-value and test statistic mean. Our test statistic t is at 1.2668. We want to look at the probability of getting a sample with that test statistic or something more extreme. So we look at the area to the right. The area to the right of that t-value is 0.1048. But since this is a two-sided test, we have to ask, what about getting the same test statistic in the opposite direction? So a negative 1.2668. So we get a mirrored area on the left-hand side of the graph. If you add these areas together, you get a p-value of 0.2096. To wrap up the problem here, we will have our conclusion that the p-value of 0.2096 is greater than 0.1. Thus, we fail to reject the null hypothesis in favor of the alternative hypothesis. There is insufficient evidence to suggest that Mr. Morehouse's students have a mean score on the AP statistics exam that is different than the mean for the state. Thank you for joining us today. I will leave you with this stirring quote by Dwight Schrute.